When renovating your house, the first thing to think about is how much you're going to spend. Your budget is going to be really, really important in your decisions you're going to make. Is this a house you're going to live in for a short term, or is this going to be a long-term proposition for you? Because it'll have an impact on your project length and cost. So you may want to just do a light touch, which is fine, or you may want to go the whole hog and do a full strip back and full renovation. Now, this stand you're currently stood in is going to be very useful for you as an aid to work out the processes, legislation, and also the terminology used in the whole retrofit market. When retrofitting your house, you must be aware that certain standards are available. Now, some are mandatory and some are voluntary. Now, in the mandatory situation, building regs kick in quite quickly if you're doing a full strip out of your property, doing a knock-through, for example, from one room to another, or you're building an extension. Now, when you're building an extension, SAP calculations need to be carried out for building regs compliance, and this will also deliver an EPC rating. Now, EPCs aren't particularly important in the retrofit market generally, but they do come to a fore if you're looking to sell your property on, or if you're going to be letting the property out. You may wish to go further than you might initially thought and have a really high performance house in terms of thermal efficiency. If that's the case, then there are various voluntary standards you can go with. So for example, there's a government-led example of PAS 2035 if your property or your project may be in a grantable status. Alternatively, we have AECB Carbon Light, which is a very good method of making a high-performance, energy-efficient home. Or if you wish to go the whole hog, we can go through to Passive House Enefit.
A lot of it, I think, with Enefit is about the standards and the quality that really bring these things together. It's about using the building physics and making sure it works to get that ultimate comfortable building. That also ultimately reduces your carbon footprint, your heating demand, your reliance on heating, your issues with moisture and things through the building as well. So it's a really high quality standard. What's quite interesting now, there's also the standard, the AECB standard, which is slightly lower in terms of its overall target performances, but again, very much leads on all the passive house principles and the building physics associated with that. And again, quite a rigorous checking in terms of certification.
Carbon Light is for energy efficient, high quality buildings. It's energy efficient, and that should be measurable on your bill. That means it's insulated, it's got an efficient heating system, comfortable and healthy. It's much less drafty, it's low carbon, and it's quality assured.
Carbon Light's the standard where you can demonstrate what the energy efficiency of the building is going to be. It uses passive house methodology. It gives you that stepping stone to make sure it's a robust and long-term renovation for an energy efficient house.
There are 3 versions of Carbon Light: new buildings, there are existing buildings, and there's a step-by-step method.
With heat pumps coming in being a lot more efficient these days, as a step-by-step, you can get yourself off gas straight away, get to the heat pump, envisage some fabric steps that you can do over time. It just allows you a bit more flexibility because the heat pump can cope with a little more heat loss, as it were. The type of people that would go for it could be anyone really, but especially people who know they want to be comfortable, healthy, and do their bit for the environment and future generations.
Why use a building standard? A standard ensures you get what you expect. The Carbon Light certificate shows how your building is insulated and energy efficient, comfortable and healthy, uses low carbon heating, and quality assured. It shows the requirement and what you actually achieved, and it also gives the signature of a certifier to prove that you've done it. It's a target, yes, but it's also a way of getting there. It's also training for those involved, and it's checking that you meet that target.
It's just making sure that what you've drawn gets built that way. Making sure that there is continuous installation around the building, making sure that things are airtight and installed properly, asking for photographs and evidence of installation, and trying to work as a team with the builder.
So if you want to find out more, you can talk to a Carbon Light certifier. You can find one through our directory. You can join the ACB community to see webinars. It's really fascinating seeing people's journey, actually. And we have more coming up all the time. And those of you who want to be a bit more hands-on, you could do some of our training and go into it in a bit more depth.
Roughly 60% of your total energy usage in a home is attributed to heating. So this has a big impact on your total energy usage of a house. So what we are talking about is what we call the peak heat load of a property. And this is measured in kilowatts. So your peak heat load is how much energy is required to heat your property when it is below freezing outside. Now, this is a very important calculation that needs to be carried out to determine the suitability of various different heating systems. This then follows on to your space heat demand for the whole annual period, which basically tells you how much energy you can use over the whole year. Before you consider your heating system, we must consider ways of keeping the heat in our property. So we're talking about insulation, airtightness, and the like, which we'll talk about later. So we class it as the fabric first approach. So the idea is we have to think about the insulation levels in our homes. So insulation levels are measured in what we class as U values. As a simple reminder, the lower the number, the better. Now, when building regulations apply, there are certain standards that need to be adhered to in terms of the levels of thermal performance. Now, when you're talking about U values, it talks about the whole build-up, say, for example, of a wall. So that's the actual fabric, the bricks, mortar, so on and so forth, and insulation and plaster and the like. Now, any specific insulation material will have what's classed as an R value, which is the resistance to heat loss.
When looking at the windows, there's some really key building physics things that I'd like to quickly explain. U value through the glass, like I said, 0.5. U value through the frame, probably about 1. U value through the wall, maybe 0.1. So the frame is the weakest point in the whole building. So the more you can do to insulate over the frame, the better. The less frame you have, the better. So if you had a window that was maybe a 1980s style, divided into with maybe a little fan light, that's probably going to be about 30 to 40% less efficient than a full window like this. So the other important thing there, like I was saying, is trying to insulate over the frame. So if you're doing an external wall insulation scheme, it's very good to have an internal opening window like this one, because you can get more insulation over the frame. Also, the internal windows are very nice because you can clean them from the inside and you can ventilate using a tilt and turn to ventilate at night, but also be secure. So if you're doing internal wall insulation, the reverse is true. So you would have a more standard UK window opening outwards. So you can put more insulation over the frame on the inside.
Another point to consider is what we class as the air tightness or air changes in a property. Now, there's pointless spending a lot of money on lots of lovely insulation if your house is drafty, because drafty houses tend to be cold. But we also require fresh air when you require ventilation. So there's two things to think about. One is what we class as air tightness, and the other one is classed as air changes. Now, air changes, one air change basically means that we are rechanging all the air in one particular room or house in 1 hour, okay? And it's dependent on the volume of the property. Air tightness is respective to the actual fabric of the building, so therefore the actual walls, how much air passes through that. Now, there are certain standards that would need to be required with building regulations, and how this is carried out is what we class as a blower door test, where effectively the engineer puts a fan in the front door and effectively measures the differential of air pressure inside and outside the building. Now, this can be very, very important when designing your house and also designing your heating system, because the more drafty it is, the higher the heat demand is going to be.
If you take a new build house, built to current building regulations, you're probably only needing to get to pacifiers, probably only needing to increase the insulation by about 5-10%. So really small, whereas the air tightness can contribute 40 to 50% of those losses. So it's really, really significant if you think about it. Often you'll find that your house is probably the coldest on a windy day. That's because of its air tightness. What it's about really is stopping air and heat leaving the building. So typically the number of sort of air tightness barriers are. So you've got polythene, which is completely doesn't allow air through. Then you have things like these membranes, which allow air to not go through. But it allows water vapor to go through, so it's still breathable, like your Gore-Tex coats. So getting your air tightness strategy and that quality to detail is really, really important. So what's important is to making sure that all the joints, so your joints between the windows and your air tightness on the inside, is well taped, and you have tapes and membranes that are going to last. So ones that will move with the building and make sure it's completely airtight. Trying to get down to sort of the Retrofit standard, you're talking really of getting your air tightness holes down to about the size of a beer mat, compared to building regulation of a current building, which is probably the size of an ATM or window in the total house. So you really are trying to get those things down. So it's a real attention to detail.
When looking to insulate your property, one thing you may want to consider is internally insulating your external walls, so effectively lining the inner skin of your property. Now, this has multiple benefits, but one of the most important things you must think about is what type of wall do you actually have. In older properties, we often have what we call a solid wall construction, and solid walls effectively are vapor and moisture permeable. This basically means that the moisture can travel from the inside to the outside of the building, also from the outside to the inside of the building. So stopping that from happening is a bad thing. So the choice of insulation materials and also final finishes is really, really important. So we must use insulation materials which are vapor permeable to allow that to happen. Now also, when insulating in the internal skin of your walls, there becomes other benefits. You're creating effectively a moisture buffer by doing that, and effectively increasing the internal temperature of that wall, which limits the chance of having condensation. Now, thermal bridging is a terminology that you'll come across occasionally when you're looking at retrofitting a house. What a thermal bridge basically is a direct connection from the outside of the house to the inside of the house. Now, we often find this in older houses where we have solid walls, but also sometimes we have it in more modern buildings where we have like a sort of a window reveal where the window reveal has been closed off effectively and you have a direct connection to the outside. Other sections can be sometimes window lintels or door lintels, or another typical one is effectively where you have an external solid wall which butts onto an internal solid wall and you have a thermal bridge coming through that. Now,
for instance here, if we were doing internal wall insulation to the outside of the house, and this is an internal wall, this internal brickwork wall is running through the insulation to the outside. Therefore, heat can transfer very quickly through this wall, bypassing the insulation. So it's a bypass, a thermal bridge. So what can you do about that? So the type of things that we would do to try and reduce that thermal bridge is one of two things. You could return the insulation along this wall, so by which making the path that the heat needs to transfer longer if it's going to try and get in from the brickwork straight the way through, or through the insulation here. So that is one way of doing it. Another way would be, which we sometimes do, which is better, would be to cut the wall back and to then thread the insulation through, refixing the structurally the brickwork together, because obviously taking out the brickwork would make the building less stable. So you need to make sure you've got an engineer involved in terms of the calculations to make sure that what you're doing to stitch it back together again is adequate. So another area of a typical thermal bridge would be around the windows. So what do you do about it? So as well as the airtightness, and making sure your airtightness taping is really good in that corner, the other thing you can do is make sure if you're doing internal wall insulation, it's wrapped around onto the frame, or if you're doing external wall insulation again, the insulation is wrapped onto the frame. So you're continuing that layer of insulation as far as you can.
So in summary, you must think that all these different elements you have to consider together. You have to have a holistic approach for the whole project because they're all interconnected. You cannot think of these things in isolation because when you change one element, it can easily directly affect another element. So having this holistic approach and taking all in one fell swoop is very important.